The aurora is a stunning display of Earth's magnetic field in action. It's best seen at the poles, but across Earth, it's protecting our atmosphere and all life on our planet. This vital protective shield is generated deep within.
The way a magnetic field is generated inside a planet is when you have convective motion in a fluid that is capable of conducting electricity. And in the Earth, that electrically conducting fluid is liquid iron. And the molten portion of the Earth's core is a place where these motions take place, and it can set up a magnetic field.
Just like Earth, Mars once had a molten metallic core, generating a magnetic field around the planet. Auroras danced above Mars's poles, protecting its atmosphere and seas below. But the field didn't last.
In the oldest rocks on Mars, you see evidence of a once powerful magnetic field. You get to the younger rocks, the rocks that are 3 billion, 2 billion, 1 billion years old, no evidence of a magnetic field whatsoever, and there is no intrinsic magnetic field on Mars today.
500 million years after it formed, Mars's magnetic field dies out. The bright auroras above its poles slowly fade away as the shield that protects the planet shuts down for good.
Once it stops, then what happens is all the atmospheric components, things like hydrogen and oxygen that make up water, they get stripped away because you don't have the shield, the magnetic shield anymore, so the high energy particles that come in from the sun and from outer space, they begin to strip away the components that make up water.
Without its magnetic field to protect it, Mars's atmosphere and then water slip away into space. So why did Mars lose its protective shield? What happened deep beneath its surface that stopped Mars from developing like Earth? The answer lies at the beginning of Mars's story, at its very creation. $4.6 billion years ago, when the planets were forming from the dust clouds circling the sun, early differences between Mars and Earth set the young planets on very different paths. Mars forms further from the sun, where crucially, there is less rocky material to build a planet.
Mars is different because it's not just further out, it's actually much smaller. If a planet gets to be too small, it just freezes all the way through.
Mars is just half the diameter of Earth, meaning its core cooled more quickly. And so it lost the heat that powered the dynamo that generated its protective shield. Mars's small size, condemning the planet to die.
The question we all want to know is, are we alone? And now we have eyes on the ground. Perseverance is ready to answer that question for us.
Touchdown confirmed. confirmed. Perseverance will safely.
For the last 4 years, I've been recreating the surface of Mars in my lab at the University of Oxford. What I've most been interested in is whether I could recreate lakes and other liquid water environments that might have existed on the surface of Mars about 3.5 billion years ago. Where it gets really interesting is that now NASA has landed a rover, the Perseverance rover, right in a crater that might have once hosted a lake. Although there's no water on the surface of Mars today, there is inescapable evidence that it was once present. When you look at it from space, you'll see certain features that jump out at you as being quite similar to those we have on Earth. You'll see sweeping valleys that look like they were carved from liquid water.
These are actually pebbles that are a few centimeters in diameter. What you can see when you look at the pebble outlines is that they have rounded shapes. So they've been basically rounded during a transport process. And they're too large to have been moved and rounded by wind processes. And so the only way we can actually get this rounding is by water flow.
You'll see gigantic canyons. This one here is the Valles Marineris. And this thing would stretch from Los Angeles to New York. This thing is truly colossal.
And I remember when this image first came up and we were all huddled around a giant screen looking at this. It actually took us a while to really hit home. Oh gosh, actually this is the first evidence from on the ground of water flow on Mars.
We see great big ice caps at the poles, much like we do on Earth as well. We see signs from space that are immediately recognizable as great big channels, enormous floodplains, the largest in the solar system, that would have excoriated their way across plains as large as the continent of North America. We see chemical signatures, we see minerals that have water locked in their structures that could have only formed when that water was freely available. And we also see both of these coming together in the form of certain features that we know from studying them on Earth only form where there's bodies of water. Where Perseverance is sat is a crater called Jezero, and why Jezero crater was selected is that it combines these two key indicators of water in one site. And how deltas form is where you have a river flowing across the surface of a planet, and in its water it's containing all kinds of churned up sediments. And then as soon as that river reaches an open body of water, like a lake or an ocean, it dumps all of that sediment load. Why the Perseverance mission is so exciting to me is that for the past 4 years, it was those carbonates that are found in its delta that I was trying to recreate in my lab. Perseverance has been in the making for a very long time, and it's a roving scientific suite of instruments. It's a moving laboratory, and it's absolutely incredible the things it can do. So to finally get to hear the sounds of grains of sand being turned over, and the sounds of that very thin atmosphere being blustered around in this crater, it's absolutely incredible. The first times I saw the pictures from the surface, it was like being in Star Wars and learning about whole new places. I couldn't believe it, and here 5-6 years later I am with my PhD on the surface of Mars. I feel very, very fortunate.
Altimeter data confirm that Ingenuity has performed its first flight of a powered aircraft to another planet.
What's incredible about the little Ingenuity craft is that this is the first time anything has been airborne on another planet at all, not just Mars.
So the image we're looking at on the screen is the image from our onboard navigation camera showing us hovering above the surface of Mars. How incredible!
The idea is that it might be able to scout ahead to places of interest for future astronauts and look for any hazards. Perseverance has 4 main scientific goals. First is to search for habitable conditions. The second is it's interested in searching for biosignatures. The third mission goal is to harvest and then cache together samples of interest to return to Earth. The absolute dream is to one day have a sample of Martian soil returned from Jezero crater from those carbonates that you can see from orbit, and to compare that to the kinds of crystals that I was forming in my lab, and just see how similar are they, what do they look like. And the final goal of the Perseverance mission is to prepare for humans to come and live there one day. People who are fit, people who are top in their fields, people who are experts, people who have a spirit of adventure. But I would say most critically, you need people who have the right temperament.
Think about a mission to Mars. What is it? Is it outdoor stuff or is it confinement? And then I see somebody that says, I have a stamp collection, I do a lot of reading, I enjoy watching movies, and I'm thinking, that might be good for confinement.
Artemis is a key step in getting humans to Mars. Right now, launching humans from Earth is extremely expensive because we're just so heavy getting off this gigantic rock. Instead, if we can have a base set up on the moon, we can have supplies ready to go from there, manufactured on the moon, that can then be launched straight to Mars. And so this makes it cheaper and easier to be launching things not just to Mars, but perhaps around the solar system as well. Once you've got to Mars, there are a whole host of problems that you wouldn't even think about based on life on Earth.
So you need something to protect you from essentially exploding, or at least having your skin all stretched out and the blood boiling and getting the bends, things like that. The way spacesuits are designed now, they're mostly pressurized spacecraft. Essentially, they're almost like a mini spaceship.
Things like, how do you maintain water? How do you recycle your water supply? How do you recycle waste?
Here we are at the throne. Number 2, right here. It's pretty small, so you have to have pretty good aim.
How do you keep making the best of everything you've got without throwing things away? And they're all problems that we're going to have to overcome if we're ever going to be a spacefaring interplanetary species. I've had a very long time to think about whether I would go to Mars, and so I'm not being flippant when I say yes, absolutely. Would absolutely love to go. It would be the most fabulous adventure. There'd be so much to do and explore, and so many questions, endless questions. So yes, absolutely.
So humans are going to Mars, and soon, lots of them. SpaceX could be going as soon as 2026, NASA and China by the 2030s, and India, Russia and the United Arab Emirates are all planning on it too. But what happens when they all get there? How can we actually survive? Well, some lucky scientists have already been there. Okay, not really. They're living in a Mars simulation right here on Earth to troubleshoot what could go catastrophically wrong when they do go to Mars. It's time to explore the unexplored. Okay, let's break this down into 2 key challenges we're going to need to overcome if we go to Mars. The physical and the psychological. Let's start with the physical. In many ways, Mars and Earth are quite alike. It has a similar dry land mass, volcanoes, craters, and its days are just 37 minutes longer than ours. What would you do with an extra 37 minutes? But that is where the similarities end, and it's the differences where the problems start. Gravity is just 38% of that on Earth. It means that you can jump higher, but you'll lose muscle mass. Imagine Dwayne "The Rock" Johnson training his chest every day with an 100-kilo bench press to maintain that impeccable physique. Suddenly, you land on Mars, and all that's available is a 38-kilo weight. Over time, his chest is going to get weaker and weaker. And it's a similar situation for astronauts going to Mars. Then there's the atmosphere, which is incredibly toxic. It's around 95% carbon dioxide. And to make matters worse, Mars is bombarded with radiation. And you get the idea. Mars is extremely dangerous. But luckily, there's a team of scientists who are actively trying to resolve these problems before we get there.
So when we talk about Mars simulations, what we're doing is we are trying to mimic the surface phase of a human robotic Mars mission. There's a million things that can go wrong. So when we think about Mars, we're talking about a world that is up to 380 million kilometers away from the Earth, which happens to be about 1,000 times the distance to the moon. And so it's probably 1,000 times more things that can go wrong. What we learned through our missions, it's not only the big things that are challenging, it's the small things. Think of being in the spacesuit. Despite the air condition, you start to sweat, but you cannot scratch your nose in the helmet, obviously. So little things like a little piece of foam where you can simply rub your nose into it and make sure you don't sneeze inside the helmet, which is a very bad idea, by the way, is a little thing that doesn't sound very glorious, but it's the things that make your work easier. And really making sure that you have gone through the ins and outs of those little details can be a game changer. We have been doing those Mars simulations for 13 campaigns now, since almost 20 years now. And there's literally hundreds of experiments we did, and many of them went wrong or did not turn out the way like we expected them to do. And so we live and breathe the mantra of fail fast, fail cheap, and have a steep learning curve, because that's where you get better. We died many deaths, simulated, of course.
So gravity, atmosphere, and radiation are not actually the main concerns. These are the big things that we already know about, that we can create technology to help mitigate them. It's the small things that we don't know about yet. They're what could kill you, and there's a lot of them. So far, the answer to most of the physical challenges has been better technology and better spacesuits. But physical survival is only part of the battle. The team are also pioneering incredibly advanced psychological studies to figure out who will be the best humans to go to Mars.
We think that there's no such thing as a born astronaut. When we select analog astronauts for the Austrian Space Forum, this has been done very, very carefully. It's a multi-month process. We're evaluating, we just did a recent count from the last class, 637 individual parameters, anything from your cholesterol level to the length of your pinky finger and your ability to entertain little children and psychological factors and so on. You're much more looking for team players who are outstanding when it comes to health, but they also have technical competence, but at the same time who are also to display social warmth. They know how to tell a joke in the airlock at the right time. They know how to cook. They know how to do a magic trick. They can play the guitar. They can also settle down a broken leg or so. We are not looking into psychological clones of each other, but they need to complement each other. And so we're looking, actually from the anthropometric point of view, we're looking for the average Joe, the average Jane.
Or an average Josie?
So we have people who, in the beginning, who have a high technical competence, but then the work doesn't stop here, because you need to continuously monitoring the activities throughout the mission. That's exactly what we're doing with our simulations. For instance, we are in a previous experiment in 2018 in Oman, we had an artificial intelligence machine learning algorithm actually, who was looking into the pitch of the voices when people talk to each other. And we know when people are under stress, the average pitch shifts just slightly above the average. Or for this mission in Israel right now, we had one of the experiments, was a fantastic experiment. The astronauts would have locators, so we could produce heat maps where the astronauts would congregate throughout the mission, or also relative heat maps, how much physical spacing they have in between them. If you don't like somebody, you tend to increase the distance, for instance. And so we're looking at the methods that tell us, here's a stressful situation emerging before the people would realize it. And magically, then everything goes according to plan. And so it's about keeping them functional, by keeping them happy, by feeding them well, no food, no fight. But also making sure they don't smash each other's heads before leaving the lunar orbit.
So, with the right training, technological development, and people management, Dr. Gromer believes that we can definitely survive on Mars. But so far, we've only been focusing on a finite scientific mission. Go, survive for a bit, and then return. And that's understandable, given how many risks there are for even doing that. But this hasn't stopped people from dreaming even bigger. Elon Musk has famously said that we're going to Mars for good, to become a multi-planetary species. Some scientists have taken this and come up with some scary, speculative solutions to explain how we might survive. One of those is through mutations. The high levels of radiation on Mars could cause our bodies to change, and it's possible that some of these changes might actually help us survive. It's hard to predict how quickly this might take and the effects that it might have, but some scientists say that it could take just a few generations. Like, we could see changes in our skin tone to deal with the radiation. Could we go green? Our bone density might alter to account for the lack of gravity, and we might not even need our immune systems because we'll be living in such a sterile environment. But all of this is only relevant if we're actually going. Will we really ever be setting off to Mars for good?
Yes, we will. I can give you this in written. It's only a natural process. I think at the core of our beliefs and of our heart and our DNA, we are a migratory species. Our children and grandchildren will look up in the sky to the moon and see little dots of light out there on the lunar surface saying, we are out there. It's a statement to the universe. And the same will happen to Mars and the worlds beyond. It's just a matter of time.
In 1996, scientists announced they'd found evidence of possible Martian life. But Mars is a frozen desert planet. Its surface is completely uninhabitable. So could these strange shapes really be ancient alien fossils?
Release and liftoff.
And why do scientists think they might be able to find more of them?
I've always loved space. There's all kinds of things moving around, and we have no idea what's out there.
Planetary scientist Nina Lanza knows it can be difficult to interpret images from space.
This is Percival Lowell, who was an astronomer in the 1880s who was obsessed with Mars. He made many observations of the surface of Mars using telescopes on the ground on Earth.
Lowell's maps of Mars led to an idea that has enthralled us ever since.
What he thought he saw were these canal features. He thought he could see signs of a civilization on the surface of Mars. And these ideas had a huge impact, not just on science fiction, but also actual science.
So in 1964, when NASA's pioneering Mariner 4 probe reached the Red Planet, the public eagerly awaited their first look at the alien world.
Mariner 4 was the very first time we had close-up images of Mars from a spacecraft. People, when they first saw them, were incredibly disappointed because they looked nothing like the Mars of our imagination. There were no alien civilizations, there was no water, there were just a bunch of craters, and it really looked like the moon.
But just 7 years later, Mariner 9 made scientists think again. Its more powerful camera revealed something remarkable etched on the Martian surface.
This is an image from Mariner 9, and it's a really important image because it was the first time scientists saw evidence that there might be something more on the surface than just craters. This is a very sinuous channel that looks like it was carved by flowing water.
Each mission that followed has unearthed more evidence that Mars was not always a dry, frozen planet.
The Viking orbiters sent back some incredibly beautiful images, things like these flowing channels and teardrop islands, both of which suggest that water was once abundant on the surface and flowing, making these features. Mars Global Surveyor sent back this one, which shows a feature that looks like a beautiful river delta. The twin rovers Spirit and Opportunity found dramatic evidence. These are hematite spheres, and they form in water. This is a vein of a mineral called gypsum. So gypsum is a mineral that not only forms in water, but actually contains water in its structure.
It's now known that in the first 1 or 2 billion years of its life, Mars was much more like Earth. It had a thick atmosphere and was covered in rivers, lakes, and seas.
There is overwhelming evidence, just looking at the surface, that there was a lot of liquid water on Mars's surface in the past.
However, this discovery, while extraordinary, did not prove Mars also had life.
Life needs water, but that's only one thing that it needs. It also needs certain chemical ingredients and also environmental conditions before it can actually develop and thrive.
Who owns Mars? It's a surprisingly big problem. With the USA and China planning to send humans by the 2030s, and with private company SpaceX potentially sending them by 2026, it's gonna get pretty crowded up there. You can even go online and buy a bit of Mars yourself. I've got mine. So who owns what up there? And what happens if things get nasty? I think we're gonna need a space lawyer.
It's time to explore the unexplored.
Space law sounds like a fantasy job, but it does kind of make sense. Surely there must be some kind of rules and regulations. Well, yes, and it started in 1957. The US and the Soviets are in the midst of a Cold War. They're sworn ideological enemies. Suddenly, the Soviets launch Sputnik, the first ever human activity in outer space. It flies around the Earth a few times, including directly over the US. And that raised a whole bunch of new questions. If an enemy vehicle enters your airspace, then you can shoot it down. But suddenly people had to think about, where does airspace end and space begin? The prospect of war in space was so frightening, they decided to keep the war on terra firma. To the surprise of the rest of the world, they joined together and drafted the Outer Space Treaty. Finally, it's over to the space lawyer.
The most fundamental baseline principle is found in Articles 1 and 2 combined, which basically makes outer space into a kind of a global commons, an international area, legally very similar to the high seas, and no single state can act as if outer space or part of the outer space or even part of the moon is part of the national territory. It's basically open for all states, and freedom for states to be active there is the bottom line. The drafters of the Outer Space Treaty were basically concerned with two elements, if you will. One was the military use of outer space, and then the secondary subsidiary level about science. The treaty didn't really discuss things which we are confronted with today as questions, at least theoretically, like the settlement on the moon or human settlements on Mars.
So it's good that states are free to use space, even if they weren't thinking about settlement. But that wasn't the only thing they weren't thinking about in 1957. The treaty only refers to political states. It doesn't even mention private companies. So does that mean that the billionaires of the world are exempt from the treaty?
One of the clear drawbacks looking back at the Outer Space Treaty was the absence of any detailed reference to the private sector. So what you see in the Outer Space Treaty is only one almost fleeting reference to the private sector in the guise of what they call non-governmental entities. But at the same time, it made sure that the state, in this case the United States or any other state, where those activities belonged to, was the one being responsible. And then Article 7 followed that up with also liability. So not only you as the United States will be responsible for them, for whatever they do, and you will be liable for any damage they cause by doing that. So the United States cannot dodge any international responsibility just because SpaceX or Virgin Galactic or Blue Origin does something in outer space.
Okay, so I get that ultimately states are responsible for what private entities do in space, how they operate, and any damages. But what about the use of land on Mars? We're planning on building habitats and living on Mars. Is that even allowed?
So we have to make a very fundamental and important distinction between, on the one hand, the prohibition for any state to own part of Mars. On the other hand, the freedom of outer space activity, which is the other part of the global commons thing, also means the freedom of simply establishing a habitat, putting space objects there, which then serve as houses, or probably even excavate minerals locally and build a habitat from those minerals. That all is in principle, again, allowed. And of course, there is a tension between those two, because it is one thing to be allowed to land somewhere, to put people down somewhere, maybe to have them live there for 25 or 30 years. But at what point in time should we say, wait a minute, now we are moving to something which looks too much like a real colony, which is prohibited by the Outer Space Treaty. But again, that question has not been solved yet.
But it's not like here on Earth, where if you break a treaty, we can physically take action. Mars is over 300 million kilometers away. So if the USA or Russia or China or a private company starts breaking the rules up there, wouldn't it be pretty hard to stop them?
Next question is then, of course, what happens if a private entity disregards the international rules of space law? Well, if that happens, then of course the first line is that the operator who goes beyond the terms of the license will be held criminally liable under the laws of his own country. It becomes a little bit more complicated at the second level when we go to the international arena. Either these states have to agree to a tribunal, or they have to sort things out on a diplomatic level. And of course, then the reality of the international community kicks in, that the bigger you are as a state, the more you might get away with.
These are all crazy scenarios that could arise in the future. And talking of the future, many people see Mars as a future second home for humanity. But how would our laws on Earth work in space? And if no country is allowed to claim sovereignty over celestial bodies, then how will it be governed if there are communities and multiple generations of Martian people?
But of course, at some point in time, certainly when they start living there, knowing that they will never return to Earth, when they probably get babies there who have never been on Earth for any part of their life, there will be a tendency for those quote-unquote colonies, I prefer to use the word settlements actually, to say, well, we don't want to be ruled by this earthbound state anymore, because they have no idea what it means to live on Mars and to be safe on Mars. So we want to create our own legal regime, and sooner or later that may actually become, we want to create our own state. I often compare this with the Pilgrim Fathers who went to North America, and then after a number of years said, well, why are we still paying taxes to the British king in faraway London? So it took a war of independence before the United Kingdom finally accepted, okay, let them be on themselves, let them be their own state. I just hope that when that happens in space, we are more peaceful as terrestrial states in allowing those to go out on their own. But that's still decades away, if not much further.
If my first chat with a space lawyer has taught me anything, it is that there is still a lot of grey area in space law. If we want humans to play nice on Mars, then we're going to have to answer a lot of these unresolved questions. And if you're silly enough to have fallen for one of those bogus websites that claims that you can buy a piece of land on Mars, well,
the paper is just worth the paper it's written on, and it doesn't give you any title. Don't expect to reap any benefits from it.
The Mars rovers have really captured our imaginations, I suppose because they genuinely are explorers in the old-fashioned sense. You know, they're the extension of our senses to the surface of another world. But they've also been very important scientifically, because you can't really get to know another planet from orbit. You've got to get down onto the surface, you've got to touch it, you've got to dig down and examine it microscopically. And the rovers really have, by doing that, made some extremely important scientific discoveries. One of the most significant of those discoveries was made in November 2004. The Opportunity rover was examining an impact feature called the Endurance Crater, when it detected deposits of a remarkable mineral. This is the world's largest salt works on the Baja Peninsula in Mexico. And what they do here is just pump seawater into these lagoons and let it evaporate. And what they're after is this stuff, which is sodium chloride, table salt. But at different stages, different salts, or different minerals crystallise out. So all the things really that are in seawater emerge, crystallise out at different stages of the process.
In one of the lagoons, pond number 9, the seawater is at exactly the right concentration to precipitate out these beautiful crystals that cover the entire floor of the lagoon. This is gypsum, and it's exactly the same stuff that Opportunity found on the surface of Mars. Now, what's interesting about that discovery is how you make gypsum. You see, its chemical formula is CaSO4, so it's calcium sulfate, dihydrate 2H2O. That's water. So the only way we know of, the only way to make gypsum here on Earth is to have calcium and sulfate ions in the presence of liquid water. So large deposits of gypsum on the surface of Mars tells you that there must have been big areas of water present for a very long time. The discovery of gypsum has helped build a picture of an ancient Mars that was much warmer and wetter. Subsequent discoveries of gypsum in networks of sand dunes suggest that large areas of Mars were once covered in standing water. And where there is standing water, there is the chance of life.